All right, 8.4 day 3, using the standard normal distribution to calculate z-scores, and then going backwards and calculating values that we need, but we'll get there in a second. So we need to use our z-score formula. This is our z-score formula. So z stands for z-score. That Greek letter mu is for the mean. X is our data value, whatever value we're talking about in the question. And sigma, lowercase sigma, is standard deviation. So a distribution has a mean of 71 and a standard deviation of 6.2. Find the z-score that corresponds with, so mean is 71, standard deviation is 6.2. So our z-score formula is x minus mean over standard deviation. So for letter A, we have 64 minus 71 over 6.2. We know it's going to be negative because 64 is less than 71, so it has to be less than the average, or 0. We get negative 1.13. Letter B, same thing, 86 minus 71 over 6.2 gives us a z-score. It's going to be positive now because 86, of course, is above the mean. We get about 2.42. And that's just using a regular calculator, nothing fancy. Now, number 2 here, standard deviation of distribution is 10.1. We got an x value. So we got our sigma, we got our x, and we got our z-score. But we don't have our mean. So that's what we're going to have to work towards to solve. So again, we're still using our z-score here. But now we know our z-score. We know our x value. We don't know our mean over the standard deviation of 10.1. So then we just solve for mu. The first thing we'll do is we'll multiply by 10.1. These cancel out. We get negative 3.737 equals 72 minus mu. We'll subtract 72. Negative 75.737 equals negative u. So we just kind of flip that around, and we get the mean is equal to 75, positive 75.737. So if we have a z-score of negative 0.37, it's really a value of 75.737 with the mean and standard deviation, or sorry, the mean is that if the x value of 72 has a z-score of negative 0.37. So let's take this a step further. Let's put it with some words, a word problem here. Survey indicates that a person spends on average 95 minutes in the grocery store per week with a standard deviation of 19. We got our mean, standard deviation. Find the percentage of randomly selected people that will spend more than 75 minutes in the store per week. So we know the mean is 95. 75 minutes is less than that. We'll say it's about here. And we want to spend more than the 75 minutes. So we want the area to the right. So first, we have to find a z-score. So 75 is our x value minus our mean over our standard deviation will give us our z-score. And if we calculate that, we get negative 1.05. 1.05. And now we need to look up in the z-score table and do 1 minus that area, because again, that's areas to the left and we want to the right. So we look up negative 1.05, negative 1.0, 00, 01, 02, 03, 04, 05. So 1469. Whoop. That was, again, 0.1469. We subtract, and we get 0.8531, or 85.31%. About 85% of the customers will spend more than 75 minutes in the store per week. Now, we changed the game a little bit with letter B. If 3,500 people were surveyed, how many, not what proportion, but how many were at the grocery store between 1 and 2 hours? Well, this whole thing's in minutes, so we need to change the 1 hours and 2 hours to minutes. So, of course, that's 60 and 120. So we want to find the area in between those two values. 95's there. 120 would be about here. 60 would be somewhere right here. And we want the area in between. So we'll find the area to the left of both of them. Minus the area to the left of the smaller one. So for our z-score, oh, we haven't found our z-scores yet. We need to do that. So we need to find it for both 60 and 120. So 60 minus 95 divided by 19 gives us a z-score of 0. Gives us this z-score as negative 1.84. Now, if we do the other value, the 120 minus 95 over 19, that gives us a z-score of 1.32. When we find the area to the left of both of these, so we look up 1.32 in our table. 1.3 here, 1.30, 31, 32. We're looking at 0.9066. We'll do the same thing for our negative 1.84. So negative 1.8, 80, 81, 82, 83, 84. So that's our area to the left of our smaller value. So the area to the left of 1.32 was 0.99066. Area to the left of the negative 1.84 was a very small number, 0.0329, for a grand total of 0.8737. Now, that's not our answer. It said how many were at the grocery store. So we still have to multiply that 0.8737 times the number of people, 3,500. So when we calculate that, we get 3,057.95 people, and we're going to round that up to 3,058 people. Obviously, we can't have 0.95 of a person. That's messy. We don't want to go there. So that's how we can do this in word problems and things that actually are, well, useful. Okay. Now, we're going to find a z-score given a probability value. So we're going to get the area. We're going to go backwards and get the z-score and then get the x value. So we calculate the percent below the z-score. Look at the 4-digit decimal on the inside of the z-score table. Select the z-score for the value close to the 4-digit decimal. Solve for the missing value in the z-score formula if we're looking for a lot more other stuff. So we don't need that quite yet. So find the z-score that corresponds to the following probability values. So 0.870. We go to our z-score table. And instead of looking down the side and across the top, we're looking in the table for the closest number to 0.87. So if we're looking around 0.87, we got this, maybe this one. Either one would be fine. I'm going to say the 0.8708 is a little bit closer to 0.87. So that's a z-score of 1.13. So we got a z-score of 1.13. Now do the same thing per 0.04. Since it's a small area, we know our z-score is going to be negative. So we'll have to go to the other side of the paper. So 0.04. So we got, well, this is pretty darn close. That's negative 1.75. Not sure where my notes went. All right, we're almost back. I don't know what happened there. So negative 1.75. And then lastly, the 0.430. If my z-score table wants to show up. 0.430. The closest we have to that is right about here, or maybe even here. Kind of either one would be fine, negative 0.17 or negative 0.18. We'll go 0.7 because why not? Why are you doing that? All right. So we got negative 0.17. Okay. So now we're going to work backwards and actually do something useful. The height of American men is normally distributed with a mean of 72 inches and a standard deviation of 1.5. So we know our mean is 72. Our standard deviation is 1.5. Now, what height does a man have to be in order to be in the top 10%? Let's draw this out. We're not going to get real detailed. 72's here. And we want to know what cuts off the top 10% or the top 0.10. Well, our table finds area to the left. The area to the left of that is 0.90. So we're going to look for 0.90 in our table, just like we were doing here, to get a z-score. Then we'll use a z-score formula to find our x value. First, let's get our z-score. So 0.90. 0.90 looks like the closest is the 0.8997. So that's 1.28. So we get 1.28. Then we use our z-score formula. Of course, that's z equals x minus mu over sigma. So now we know 1.28 equals x, we don't know, minus the mean of 72 divided by the standard deviation of 1.5. So, of course, the first thing we do is multiply both sides by 1.5. On the right, they cancel out, which is the whole point. And we get 1.92 on the left side. That equals x minus 72. We add 72 to both sides. And x equals 73.92. So 73.92 inches, we need units, is how tall a man has to be in the top 10% of height in the population. What does it mean to be in the top 10%? Well, that means a man is taller than 90% of all American men, or they are in the 90th percentile. Of course, they both mean the same thing. Let's do this one more and be done with our chapter here. The length of the male's hand is normally distributed with a mean length of 1.886 millimeters and a standard deviation of 7.2 millimeters. What hand length does a male have to have in order to be in the top 25%? So it's really just the same thing of what we just did. So top 25%, that's 0.25, but our table uses area to the left. So that would be 0.7, because 1 minus 0.25 is 0.75. So we're going to look for the area, or the z-score, that goes with an area of 0.75 in our table. So 0.75, we got, it's pretty close there. So we get 0.67. So the z is 0.67. Now we use our z-score formula. Again, it's z equals x minus mu over sigma. So 0.67 equals x, which we don't know, minus our mean of 186 over 7.2, our standard deviation. Then, of course, when we start to solve, we multiply by 7.2 on both sides so that it cancels out on the right. We get 4.824 equals x minus 186. And of course, we add 186 to both sides. And we get an x value of 190.82. So what hand length does a male need to have to be in order to be in the top 25%? Well, 190.82 millimeters. What percentile would you be if you were in the top 25%? That means there's 75% lower than you. So that means you were in the 75th percentile. Percentile is the percentage of population less than the value. So a value of 190.82 millimeters is in the 75th percentile because it's larger, or that person's hand is larger than 75% of all just male, I guess. It doesn't say that it's American men, but males. And that's what we need to do for statistics.